Lesson 3-7, Part 2. Absolute value inequalities, the AND case. Example 1. Solve and graph the absolute value of x is less than 10. So what we want to recognize here for our solution, since absolute value of a number means the distance from that number to 0, let's see what that actually means in terms of a graph. So we have the absolute value of x is less than 10. But notice that since distance is always positive, the absolute value from negative 10 is the same distance to 0 as the absolute value to positive 10. They're both 10 units in distance, which is positive, from 0. In other words, distance is positive. So we also notice that the absolute value of negative 6 equals 6, which is less than or equal to 10. The absolute value of positive 6 is 6, which is less than or equal to 10. So both of those values are also within the absolute value of x is less than or equal to 10. Those are values of x that make that inequality true. And in fact, every value of x from negative 10 all the way to positive 10 make that statement true. So looking at that graph, what we can say is there's the graph. So we've done one part of this problem. Let's write what that graph shows. That is that x, it goes from negative 10 to positive 10. In other words, negative 10 is less than or equal to x, which is less than or equal to positive 10. And so that would be our solution. So the solution of absolute value of x less than or equal to 10 is that negative 10 is less than or equal to x less than or equal to positive 10. So it gives us a couple of rules. One is that when the absolute value of x is less than or equal to a number, we put x between the positive and negative number and include the equal sign. The other case is where there is no equal sign, when it's strictly less than. When the absolute value of x is strictly less than a number, we put x between the positive and the negative of that number with no equal sign. And in fact, both of these cases are the AND. So we can say when the inequality points to the absolute value, we have the AND case. Example 2, solve and graph the absolute value of x plus 3 is less than 8. So one of the things, remember, just solving an equation, our goal is to get the absolute value all alone or by itself. So what we'll do is we'll subtract 3 from both sides of the inequality. 3 take away 3 is nothing. 8 take away 3 is 5. We have the absolute value of 5 is less than 5. So we know, since the absolute value the inequality points to the absolute value, this is an AND situation. So we'll put x between the positive and the negative value. It's an AND. So x, there it is, negative 5 less than x less than 5. The graph looks a lot like the inequality. We don't have equal to, so we don't shade in the point for negative 5 or positive 5. We shade everything in between. Example 3, solve and graph the absolute value of x minus 2 less than or equal to 5. Key thing here is to recognize that what is inside of the absolute value is still less than or equal to 5 units from 0. So whatever is in the absolute value in this case is less than or equal to 5 units from 0. So what that means is we have the absolute value, we have the inequality pointing at the absolute value, so we put whatever is inside the absolute value between negative 5 and positive 5, including. I solve the way we learn to solve compound inequalities. I isolate x, I add 2 to all 3 sides of the inequality, and I end up with negative 3 less than or equal to x less than or equal to 7. The graph looks a lot like the inequality, except previously I didn't shade in the point because there was no equal sign. Now I have the equal sign, so I shade in the point. One little correction we will make, which we'll do in blue, is we'll make that a 7 on the right. Example 4, solve and graph -2 times the absolute value of 3x minus 2 greater than -6. Now it's true to start with, the absolute value is pointing, the inequality is pointing away from the absolute value. But we need to get the absolute value all by itself. We are not allowed, as you may recall from the previous video lesson, we're not allowed to distribute into the absolute value, and this is a great example of why, because there is a negative. If you put the negative inside, it would become positive, which would change everything in an incorrect way. So rather than distribute, we actually undo that multiplication with division, and we divide both sides by -2. But of course, when we divide by a negative, we switch the direction of the inequality. -2 divided by -2 is +1. -6 divided by -2 is +3. So now we have the absolute value of 3x minus 2 less than 3. The inequality is pointing at the absolute value, so it's an and situation. So we put the part of the statement 3x minus 2 inside of the absolute value between the -3 and the +3. Next, if we're in doubt, of course, we treat this just like an equation, and so we would add 2 to both sides. Then we divide by 3 on all 3 sides, and we get -1/3 less than x less than 5/3. Finally, we make the graph. We don't have equality, so we don't fill in the points -1/3 and 5/3, the endpoints of our graph. Finally, example 5, solve and graph 4 times the absolute value of x plus 7 minus 2 less than or equal to 10. If we're in doubt, we will treat the entire absolute value just like the variable x. So instead of 4 times this big absolute value, let's just say 4 times x minus 2 equal to 10. You know that the first thing you do there is add 2, treating the inside of that absolute value just like x. So you'd add 2 to both sides. That's exactly what you're going to do in the inequality. 2, take away 2 is nothing, and I have 4 times the absolute value of x plus 7 is less than or equal to 12. Again, don't distribute, divide both sides by 4. 4 divided by 4 is 1, and I have the absolute value of x plus 7 less than or equal to 12 divided by 4, which is 3. The inequality points at the absolute value, so it's an and, so we'll put -3 and +3 on both sides of x plus 7. And next we subtract 7 from all 3 sides to get x all by itself. So we have -10 less than or equal to x less than or equal to -4, and the corresponding graph as we have seen. And that's pretty much all there is to absolute value inequalities, the and case.